กลุ่มนึกมาทำโปรเจกต์กันเรื่อง predict ผลฟุตบอลครับตอนนี้ทีมของผม clean data แล้วก็ polar chart ของทุกแมตช์ในช่วงสมบูรณ์มาแล้วครับตอนนี้พยายาม predictive model โดยใช้วิธี support vector machine ครับโอเค fine ทำไมใช้ support vector machine
ขั้นแรกก็ลองแต่ว่าตอนไปจะทำก็
ลองหมดเลย
มีเป็นต้องปล่อยแล้วก็
ซึ่งตอนนี้ได้ accuracy ของผลแพ้ชนะจากโพล่าประมาณ60%ครับอยากจะขอคำแนะนำอาจารย์แนะนำในการสุ่มซื้อเลยขอแนะนำให้ลอง learning algorithm อื่นๆก่อน
ตอนนี้คือ
โอเค 1,520 แมตช์เป็นอันนี้ใช่ป่ะ right and then what
คือเหมือนเราเอารูปแบบพวกนั้นเราก็เหมือนเราถามต่าง
input
ใช่ครับ
โอเค good
แล้วก็ทำมีเริ่มทำซัพพอร์ตเวกเตอร์ก่อนก็มี
tell your friends what you did
so we have the data in the radar chart. So what we did next is find the difference.
Okay.
Let's find the difference.
Okay.
If the team has more in
so you always have the winners to the left or not?
Home and away.
Home and away. Good. Otherwise the result would just be one way. Okay, good. So sometimes it's 1, sometimes it's 0. Home minus away. So you get a vector of 6, right? Good. Now, what I would do is this Python. You use what? Which library? I can't see. Python. Which library? Which machine learning library? Scikit-learn or? Well, scikit-learn doesn't, you shouldn't stop with just support vector machine. Obviously, you're not getting the results, right? So maybe try neural network, try gradient boosted trees and so forth. Okay, are they any better? That's fine. So it's because you want to make it a binary, right? The point is, first of all, how many matches you have?
We have like
1,500 matches. What's your validation?
we do 70%.
730, right? Okay, fine. What I would do, by the way, is maybe do a 5-fold validation. 80-20, 80-20, 80-20, 80-20. Right? There's not a 5-fold validation loop in Python, It's in scikit-learn, right? Okay. In scikit-learn, it does n-fold validation for you as well. So you block 20%, train 80, test 20, right? And then you block another 20, you train 80, test 20, and then you get 5 sets of testing performance, and then get that average. That is your estimate. Okay. Now that number, what kind of number do you get? Okay, let's say you haven't done that. You have done 70-30 split without 5-fold. The performance of the 30% versus in training, is that better than 50-50? On the training or the testing? You should show me the confusion table, guys. Where's the confusion table? Okay, that's your confusion table. Okay. Right.
But each time that we ran the test,
Sure. Well, actually, if you change the training and validation, your model should change as well, right? Okay. So yeah, cross validation accuracy is 66% now. And what algorithm is that? Support vector machine, or what about other things?
for random forest
Right. Okay, what about ROC curve? Can you, okay, do that. Okay. What about neural network, multi-layer perceptron? I think this would be a very nice test case for multi-layer perceptron because you can add complexity, right? All you have is basically an input of 6, an output which is a binary, right? And you can vary input layers, multiple layers. Have you guys seen this thing? นัดรีบส่งไอ้โคแลบหน้าที่ทำ multi-layer perceptron ที่เราเคยใช้ทดสอนนะไม่ใช่เอาไอ้โคแลบที่เราเคยสอนที่ไปสอนเลคเชอร์อื่นนะโคแลบที่เพื่อนแฟงมาสอนอันนั้นไอ้ด้านนั้นจำได้ไหมอยู่ไหนไม่รู้ใช่ไหมก็ which one is you have to present the result like who's better and what is accuracy area under the curve, right? Right. And you also have to maybe try to vary different version of your algorithm. So instead of taking the difference, maybe you take input 6 plus 6, right? So do more. I mean, you'd have to wait for my suggestion, right? Think about it this way. Let's say you present some result and it's not that great. It's 66%. Okay. Let's say I was to be buying this project. I commissioned this project to you. My question would be, have you exhausted all possibility? Right? You tried the difference. What about individual? What about the goalies? If you add more parameter, does it help? All these questions, if you haven't done it, you've only done one version of the configuration, and it's not that great, right? So obviously, I'm not going to be happy with it. I'm going to ask, what about other version? Now, from my point of view, if you've done all the version and they're all poorly, in terms of they're all doing poorly with respect to prediction, that's fine. That's part of life. In fact, what I like to do is, well, maybe there's no time for it, but I can teach you this thing called gamma test. It's a test of estimating kind of like lower bound on error. So it's saying that if there's a lot of noise, this is the best prediction you can get. So if you get close to it, that means you're pretty good already. Okay, it's like an upper bound on accuracy. I don't know if I have time for that. I don't think so. Okay. So okay, but at least you're getting some results, and you are doing fairly okay, right? Now, again, exhaust all the possibility, all the built-in experimental design feature of scikit-learn. Now, let me show you something real quick. Okay. Now, this is called neural network playground. Let me share. Let me share this with you. แก้ไงวะ Zoom. Oops, am I still in Zoom? ไอ้นัดพี่หลุดซูมยังไง Where are we?นัดพี่เข้าซูมไม่ได้ Oh, nope, that's line. Okay, let's go to this page. Oops, nope, not this one. Share screen, go to this page. Okay. I may have shown this to you earlier. It's a neural network playground, so you can add more layers. Now, this is a case where you can do experimentation with your problem. Okay, you can't do it here because this is going to show you just 2 dimensions. You have at least 6 dimensions, right? But you can certainly see that if you add more neurons, okay, if you add more neurons or if you add more layers, it's going to try to do. It's going to be able to map to different level of complexity, right? Like something like this, that's a lot more difficult to do, right? Yeah, this is a bit more. It's a lot more difficult to do, but certainly if you keep adding more layers, more complexity, it's going to do that. Now, with gradient boosting, obviously you have to add more trees, random forest, add more tree, add more depth, okay? But why not play with neural network, okay? Since you don't have to program it. You guys have to realize when I was your age, it was very difficult to program a neural network, okay? So you have this luxury in your hand, and why not use it? Okay. Other teams? Okay. Word team. One more. Yeah, go ahead. Right. You let's say you train your neural network, it works well, right? Then in recall mode or in prediction mode, you would just make some kind of assumption that you know what the away team is, right? And then you try to do the home thing. So what you should do is, okay, this is my assignment to you. Okay, first of all, try other algorithm. Okay. Well, first of all, you have to do performance metrics like AUC, right? You have to be able to do all the ROC curve, right? And all that. Okay. Make sure you have all this in your report. Okay. Try other algorithm. Try other configuration. Like instead of home minus away or visitor, you have this home vector and visitor vector. Okay. Maybe you add home vector, visitor vector, goalie, right? You shouldn't just take one shot at it, right? That's a bit too lazy. You should try many things, try many experiments. I mean, you don't have to do anything yourself, right? Computer has to do it. Okay, just make all kinds of configuration. Then your result should be something like, you know, something like say accuracy or AUC with respect to, okay? So this would be different technique. Okay, this would be different configuration, different formulation, right? And so forth. Now, and each techniques, you can also have different parameterization, like number of hidden neurons and so forth, right? Gives you a, and I would love this, but I don't know if you can. Okay นัดที่ไม่รู้ไอ้ scikit-learn นับ parameter ให้เปล่า but anyway what would be nice if you can count number of parameter in the model. Okay, like linear regression has 2 coefficients, so that's 2. Neural network has 1,000. You know, so we want to know the level of complexity. Okay, maybe it helps with complexity, maybe it doesn't. Now, having done that, so let's do this. Let's just take, say, 5 scenarios. Okay, 5 scenarios. This is your visitor. You just pick a team. Okay, pick a team, right? And okay, let's say, what's your home team? Okay, Man U. You know your roster, right? Okay, you work out a little bit of cheat, a little cheat sheet. Let's say this is my order of battle. Okay, this is my lineup: lineup 1, lineup 2, lineup 3, lineup 4, lineup 5. Right? And when you have the lineup, you look up the strength, you get the vector, you put the model, right? And you can do this. You can do this. Let's say you want to match Man U with Liverpool. Okay, so you look up Liverpool. What in the past? What kind of configuration have they done? Right? What lineup have they done? Okay, then you can look up. You can say something like this. This is their lineup A, B, C, D, E. This is our lineup 1, 2, 3, 4, 5. And then you make this table. Okay, so, and the output could be something like a heat map. Okay, so it would be something, you know, if I knew, let's say on the day, they tell you first, you get a kind of intel, you know, oh, they're going to do this lineup. You would say, oh, if they were doing that lineup, I'm going to choose this lineup because it has the highest probability. Okay, the pseudo inverse would be to get the result and go back to the lineup. But in this case, the pseudo inverse is pseudo inverse in general setting is a lot more difficult to do anyway. So in this case, because your input is limited, like you don't have that many variation in terms of your lineup, just try them all. All right. So it's not you get the result, you get their lineup, add the result you required, and predict. Oh, sorry. Give back the pseudo inverse, which is the lineup you should start. You just try all because you only have 5 of them, say 5 lineup. Okay, there aren't that many infinite combination, right? Because you can't have goalie in the front and the, you know, it's rather limited. It's not 11, choose 11. Okay, so that would be how you would use it if you believe. Okay, now a cooler thing would be something like, you know, well, there are other validation stuff, but certainly, see, the neural network is trying to learn all this. It's quite hard. Good. Okay. Next, who's having difficulties? Okay. It's up to you guys because, you know, this is the last time you see me before you turn in the project. So if you don't have any questions, again, this is project-based learning. I don't care about the project itself. I care about the learning you get from doing the project. Yeah. Issues? Well, progress? Go. Okay. You have a, let me stop share. Okay, Wang is going to share the progress. Yep.
But it's trying using ResNet.
ResNet,
But it's
to do what?
to do an image recognition.
Okay.
But it's not that, right? It can capture something like Camino and Aptron and something like that. So
Yeah, obviously, it's very easy. Yeah.
Yeah, so we are.
So that is only the beginning, right? Your project is to take from that.
We have when we got the code is already.
Good. Yep. 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 Fine. That's good. No, this is not buying action. This is picture, right? Relation between picture and what? What's the output? In particular pictures, something goes on with something. Oh, okay, okay, okay. Ah, you guys cheated a bit because originally you were going to use the picture as input to predict response, like smile. Now you're doing association of the content. No, no, it's okay. You changed your problem. It's okay as well, but ah, okay. No, it's valid. It's okay. It's valid. It's doing a picture association. That's different from the objective you started with, right? The starting objective was picture predicts reaction. Now you're doing association of objects in picture, which is nice, but that's not the okay, reaction part. Where's your reaction part? Okay. Uh-huh. Okay. Again, this is nice, but this is also cheating because original promise was picture to reaction. You're doing clustering on the reaction, which is again nice, but that's not what you promised in the beginning. Okay, it's okay. You can cheat. It's okay. Okay, for the purpose of again, it's project-based learning. I'm not paying you to do this analysis for me. So you're definitely failing X to Y, which is what you promised. But in the process, you've learned that you can do something with X, and then you can do something with Y. You just haven't been able to do the X to Y yet. Ah, should have used that object recognition, 2 weeks ago when I suggested. Yeah, that would have saved you a lot of time because again, you just want to do the mapping, right? The idea was which object excites the viewer or makes the viewer happy or sad. Yeah. But what you've done is kind of like exploratory analysis of the X and the Y, which is fine. Okay. Now, for your sake, you should write the project as a work in progress. It's okay. You should still say, I want to do X to Y. This is my X. This is my Y. We can't get to X to Y yet. That's fine. It's fine. The project's delayed. It's okay. Part of life. But at least you are getting insight from X. You're getting insight from Y. Okay. So let's say I own this project. I'm the sponsor of this project. I don't have the insight I need yet, but maybe the insight of how are the likes and dislikes clustered, different types. Okay. A lot of people are haters, or a lot of people are admirers, a lot of people are neutral. Maybe that's insight. So this is kind of interim insight. It's not what you promised in the beginning. It's okay. That's work in progress, right? So you have to be able to salvage whatever it is. But in theory, you should have done all this unsupervised learning in the beginning. Okay. In fact, the unsupervised learning part should inform you how to create the supervised learning part. Okay. So if by next week you haven't got to that, fine. Just write it as is. Okay. So your project, the write-up has to be complete framework. And you say, there are 5 steps. I have done A and B. Okay, we haven't got to here, but from A and B, we can actually use the insight, interim insight, as it were. Right? That's great. It's okay. You know what? You can still get a good grade, but if this were a project, you wouldn't get paid. Okay? Okay. Okay. So this is like doing, you also using a priori on the reactions or just clustering? Yeah, what are you doing? Clustering, right? Okay. So there are better way of presenting the cluster result, right? What is your dimension in the clustering? 5 dimension. So use like a cobweb. This is, by the way, this is how I would present all of my clustering analysis. Okay, guys. Everybody? Yeah. This is my clustering analysis, right? I got this cluster, I got this cluster, and I got this cluster. Okay? Now, this is 2 dimension, but let's say it's 3 dimension. So this, okay, 3 dimension. What I would do as my go-to presentation is the polar or cobweb. 3 dimension, right? 3 dimension. Take the centroid, take the centroid, take the centroid, take the centroid, map them. So let's say I have 5 dimensions. Okay, this would be one centroid. Okay, now this would be another centroid. Okay, now put them together and make the thickness proportional to cluster size. Okay, so that's my picture number 1. This is what I would do. My first picture is, let's say I have 3 clusters. I would put them on top of one another on the cluster, like your friend did on the cobweb, except instead of having just two cobweb, have the thickness. Okay, have the thickness. Don't color the inside. Just make the thickness proportional to cluster size. Okay, that'd be my picture 1. Now, what else I can do? What else I can do is this. For each cluster, also do the cobweb, but now do this. Okay, this is the cobweb of the centroid. This is a cobweb of the minimum for each dimension and maximum, or 10 percentile, 90 percentile, or standard deviation, or something like that. So this gives me, for example, I can say that for this centroid, it's high on this axis with low variability. It's maybe low on this axis, but high variability. You see what I mean? So it's giving kind of like distribution picture. Okay, that is a nice picture to have. But if you can't do that, just go ahead and do, for this, you just do the histogram of 5 dimensions. Okay, it's a little bit more uninteresting. Okay, but the good thing with, yeah, then it's similar to yeah. Yep, something like that. Good, very good. Yeah. Can you adjust the thickness again to reflect? This is a little bit hard to see. Now, in the option to draw the cobweb, instead of drawing this like a flower, you should just use this pentagram or whatever. Might be easier to see. I think it's easier to see. Okay, it's not as pretty as flower, but yeah, certainly. Okay, so make the best you can, but don't give up on making predictions. Okay, I would like to see in the final some kind of prediction formulation, even if it's got terrible result. It's okay. Again, I'm not paying you. I'm just grading you on your activities. Okay, good. Okay, you มีไหมครับ how would you do your prediction, by the way? How would you formulate your prediction problem? Tell you what, I tell you what, let me help you out. Instead of going to machine learning route, since you already started with a priori, okay, how about you do basket as an input and then basket as an output? In other words, association rule mining. Right? Because your output is also a basket, right? You can have likes and not frequency ใช่ไหม your input is presence of objects. The most let's say you have common object, 10 of them, and you just do this basket analysis, right? And then you have output. Now your output is not really a basket because it's actually a distribution. Okay, it's not this picture gets a like and a frown, because it's actually you're probably going to get all. It's just the frequency. So can we convert this into association rule mining? For example, okay, to turn this into association rule mining, you can say you look at the distribution of the result and you take the two most responses. If you get smiles the most and frown the second, you get smile and frown. Maybe, I don't know. How many reactions can you have? 5 reactions. So can you get non-reaction as well? So that's 6. Let's say you have 6 reaction classes, and we have to make some kind of threshold. Now, if you get no reaction, do you get the views? Oh, okay. So no reaction, just simply no reaction. Huh? No reaction, just view and nothing. That's so all these have reaction, right? Okay, fine. Okay. Yeah, let's say we just among the reaction, you have 5 reactions possible, right? 5 reactions. So maybe you do some kind of cutoff. Okay, that makes sense. Like if you get more than, well, it's hard to do cutoff because some pictures get more percentage, right? Let's say you look at the cutoff, you look at the reaction, you turn that into percentage, and you take any two reaction that has more than 20%. You do that, any reaction. So your basket would look like this. Your basket would look like cat, purse, okay? And the output would be something like and frown. Now, obviously, you're going to get all 5, okay? But this one maybe is more than 20%, okay? So another basket would be cat, dog, and then just like, something like that. Then you can do this kind of association rule mining. So you don't have to work a lot on machine learning part, since you've done a lot on this already. Then you can use a priori, okay? But obviously that's not what you want, right? What you want really is to actually predict. You want to use this, okay? Now, how would I do this in practice? Now, this is not a full vocabulary. It's just a list of items. So give me an upper limit. How many items have you got? Like if you count the unique item, when you run the Mathematica, let's say you got 1,000. You can certainly one hot 1,000 input, put into a neural network, and then output 5 number. This 5 number has a sigmoid from 0 to 1, and this is the percentage of likes, percentage of frown, percentage of this, percentage of that. That's your ground truth. Train it. Okay? So if you can make your problem smaller. Let's say you take them, you think this is too difficult or it's going to take too long. You want to do proof of concept. You know what proof of concept means, right? Not a full scale. So you say top 50 most likely item, most frequently occurring item. Then you can do a one hot on a 50 dimension, and then output neural network of 5. Right? You can do that. Now, I would prefer you do this rather than, you know, fiddle around with association rule mining. But that's one way out. Okay? So you have to think of what you can do with the data, with the set of tools you have. Now, when I said, you know, use this is like assuming you don't have access to neural network. You only have a priori. What can you do? Okay? But that's certainly not the case. You can use, you know, Mathematica or whatever, scikit-learn or whatever. Okay? So one hot this thing, okay, take the top 50, make it more manageable. And then predict 5 numbers. Percentage of likes. Now, obviously, they have to add, in theory, add up to 1. Okay? So you can do like a soft max or something like that. Kind of normalize it. Just make this a sigmoid 0 to 1. Okay. Suicide. Good. This is what? What are different colors? Countries. And what are different, what's on the x-axis? Value of factors, right? Suicide rate, different dots at different years, right? Okay. It's a little bit hard to see. Can you draw a line between years? You know, you certainly can't do all this. You have to, this is not going to make much sense, right? So you have to sort of like break down a little bit. Maybe you plot a few countries at the same time. Maybe just Southeast Asia. I don't know. Okay. Did you look at country similarity using support SOM that I told you? Countries are different, similar. Yeah. Self-organized. Feature map. No, SOM. I sent you pictures, right? Papers that organize countries along similar dimension. Anyway, never mind. You haven't read that. That was sent quite a long time ago. Okay, well then let's say you can't plot every country all at once. So maybe you have to plot just Southeast Asian together, 5 countries. I don't know. Okay, now this is just visualization. This is the beginning of the project. Okay, what is the analysis? What can you do? Can you do prediction? Can you? Okay, let's see what your clustering look like. So your clustering, again, the same comment that I said earlier applies to you as well. Plot the centroid, and the thickness is the population or the number of, yeah? Population, in this case, I don't mean population of people. I mean population of data. So if you have 100 countries separated into 5 clusters, maybe this cluster has 30, this cluster has 10 countries. So the thickness would be 3 to 1, something like that, right? What algorithm are you using for clustering analysis? K-means? Maybe. Have you done it? Uh-oh. Yung Lanat. I would be perfectly happy with every one of you if this were 4 weeks ago. Now, you guys are allowed to help each other. In fact, to encourage people from helping each other, if you help, if your team is big and their team is small, you help them, they can write that in the report. Like, we get help from this team or something like that. Okay? So it's good for you. It doesn't reduce points from you, but it adds. Okay? So help each other if you have time. But if you don't, never mind. So you haven't done any clustering. No, you just do graph. That's just plotting. Okay. Technically, plotting is data analytics, but you know, since we spend a lot of time on machine learning and analyzing the relationship and supervised learning, you should incorporate that. Yeah, incorporate that. Otherwise, plotting is just Excel, right? If all this could be done on Excel, so don't turn it as a deliverable, as something that can be done on Excel. Okay. So what's the clustering area? A country separated into, you know, rich and high. Remember I told you guys about rich, happy, and not so rich, not so happy, and suicide rate and all that. Do cluster analysis, guys. Maybe what I should do is write what I expect at the minimum for each project, but that'll be a bit hard. Okay. Now, let's spend a bit. Okay, more questions? Questions? The word people, are you okay? You should be okay, right? Now, what's your project? No, you can send it after. Like,นัดให้เวลาเขาเท่าไหร่ดิ Maybe a week. You take an exam on 2 weeks from now, correct? So let's make the project hand in the Monday after. Huh? You guys want a week after exam? Oh, week and a half. All right. Okay. How soon do you need? Do I need to turn in your grade? Okay. So we have next week is the project presentation. The week after this is the exam. Monday afterward is exam. How about the Friday after that? Yeah. Thatไหม? Oh, we'll talk about it. Hold on. Thatไหม? Is that too late? I don't know. Check with your schedule. Okay. Okay. 11 of 11. No, that's a holiday, right? 11วันรัฐธรรมนูญส่ง report. Present is next week. And we'll talk. วันหยุดราชการเนี่ย Okay, 10th of November, 10th of December, hand in your project. 11รู้สึกเป็นวันหยุดลูก Okay, 10th of December. วันที่ 10ก็หยุดเหรอ Okay, 9th of December. ฮะวันเสาร์วัน 9th. Okay, that's it. The 9th of December. Okay, you hand in your project. Now, let's talk about what do I expect. Okay, so next week, you will get fixed amount of time, all of you. Okay. Do you guys want to volunteer who wants to go first or anything, or you want me to randomize? Yeah, I can randomize, okay? Right? So, next week, you will present, I guess, on thingy here. Okay. What do you have to present? What do you have to present? First of all, number one. By the way, I don't want just one guy speaking, right? So you guys have to take turns. Yeah? So one, introduction, obviously. What is your project all about? Okay? What is your objective? Why are you interested in this? So sort of like sales pitch kind of thing, you know, to get me interested. Why do I care about football team? Why do I care about Facebook? Why do I care about suicide? Okay? So there has to be some kind of a lead in. Okay? So I have to pay attention to you, but assuming you present this to somebody who doesn't have to pay attention to you. Now, so the introduction has to have both the motivation and the setting. The setting basically just to like scope your problem. Okay? Scope your problem. So your setting is ultimately going to be tied to your data. Like if you are motivated to analyze football, but English football, then obviously, you know, the data would be and so forth, right? Now, two. Now this is two parts. Sometimes you switch, but let's say you talk about data first. Okay, and the methodology. Now, in a lot of analysis, your presentation, your data, your plotting is the analysis. Okay, that's not good enough here, right? So your data, not only do you have to talk about the usual thing like the source and whatnot, you have to do some kind of visualize, right? At least have to see what the data looks like, histogram and whatnot. Okay, that is really technically, like I said, this is data analytics, right? But it's very surface, it's very superficial. Okay, it's something that can be done on Excel. Okay, now the method. Okay, data and method together is your what? Is your problem. Problem formulation. Okay. Now, in most paper, actually the right way of doing things is to formulate the paper, formulate the problem, discuss the methodology, data, experiment, conclusion. But in a lot of these projects, the data gets the first attention. Okay, think of it this way. If I say I want to predict A to B, I want to predict Facebook reaction from picture. That should be my formulation. Then I tell you about the methodology that's required. Then I go to the last part that talks about the data. The data is we take from Facebook. Okay, but in some of these projects, and I suspect in the future, you would tend to start to talk about data first as a motivation. Okay, so instead of data feeding into the methodology, sometimes you would visualize the data first. So you would show like, see, you can see that there's a histogram of likes and dislikes. There's a lot of likes, there's a lot of dislikes. There's a lot of picture of purse and camera and cats and dogs and something like that. Okay, so that's why sometimes you see this a lot. But technically, the flow is problem formulation, methodology, and then data. And then the experiment with the result. And this is where you do the another set of visualization, right? The conclusion table, ROC, cluster, centroid, right? You can also do, to make it interesting, compress into 2 dimensions and then display, right? So dimensionality reduction is a very good thing to have. if you have, yeah, for example, you're doing the countries, right? Country and suicide, then you can say, well, you know, if I put in them 2 dimension, this is Thailand, this is Myanmar, this is Laos, this is Canada, this is Peru, this is blah, 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 right? And then you can use color to designate that they belong to the same cluster or whatever. Yeah. So you have to say 5 cluster. So red, green, blue, yellow, pink, I don't know. Something like that, right? Now, I would suggest that you do cluster analysis in the original dimension, then compress to show. You don't compress and then do the clustering. Okay? You lose information that way. Okay. So something like that. That'd be experimentation and result. And then you do some kind of conclusion, future work. What happened? The story. Okay. What did you learn? What was the difficulty? What did we? What was the obstacle? What would we have done differently? How are we limited by the data set? Okay. For example, if we had a more granular data that separates Facebook response into demographic, we would be able to do better analysis. Or if we had more psychological metrics like mental health that is applicable to all countries, then we can use that. But we didn't. You know, all kind of limitation. You can discuss all that as well. Okay. So this would be sort of lesson learned. So you learn from the result of the analysis, but you also learn from the experience. So if you couldn't get the right accuracy, if you get very high accuracy, the insight is from the model. Right? But if you get low accuracy, you can also have an insight that say, this formulation doesn't help. It's a little bit better than random. Okay, you can say that. That's an insight. Okay? So an insight can be directly the result of a well-tuned, a well-defined, well-developed, highly accurate model. But your insight can be from the experience as well, from the experiment. We found out that this technique failed, or it didn't work, or the data is too noisy. That's insight, right? Okay. Now, I'm grading you guys on completeness. In fact, that's how projects should be graded. Okay. You know, I should be happy to pay for a project that's well done, fulfills all the objectives, even if my objective is to predict A from B, and the prediction is not highly accurate. The guys have done everything, have exhausted everything, but the data is not that predictable. Okay? So if you come up with a really good project that predicts the local weather 10 days ahead, I can guarantee that you will not get any good prediction result. Yeah, but it could still be a good project. Okay. On the other hand, if you're predicting stock price for tomorrow, given price from today, any moron can do that. You can get 80%, 90% accuracy, and I will not pay you anything. Okay, because I can do that with Excel. Okay. So again, the difficulty of the problem is what limits the accuracy. Okay, you have no control over that. Okay, but your ability to try to milk the best out of your data, to extract as much information from whatever it is you're trying to learn, even if it's difficult problem. Yours, for example, is quite difficult because something personal is going to be predicted at a macro level. That's hard. Okay, that's fine. That's fine. Okay, yours is going to be difficult as well because, you know, relative strength. That's what. That's like an overall scoring. It's overall rating of players. But actual dynamics of play is different. Okay? Fine. Completeness, thorough, professionalism. Yeah, by the way, guys, that's the key word. At the end of the day, you are graded on your professionalism. Okay? Meaning it's a complete project, you explore every possibility. The result sometimes is not usable. That's fine. Again, a professional project with millions of dollars will not predict earthquake 10 days ahead of time. Okay? If I'm silly enough to pay people millions of dollars to make 10 days earthquake prediction, that's my problem. That problem is not going to yield anything good in terms of prediction, but it may yield a lot of insight along the way, like the clustering of earthquake behaviors or something like that, or inter-arrival between the first earthquake and aftershock. Maybe you have something definite there. So you can't predict the earthquake, but if you knew that the earthquake has happened, you can predict the aftershock. Okay, fine. That's the best you could do. But you say today, what's the probability there's going to be an earthquake next Monday? Nobody's going to be able to do that. Okay? Right? But then you came up again with interim or something else that you can use from the data, from looking at the data. It tells you that if it happens on Monday with this magnitude, with this pattern, then there's a high likelihood that it's going to happen again on Wednesday or something. Okay, fine. Okay? Yes? Well, make division. How many teams you had? You have 3 hours. The reason I don't know is because I don't remember how many teams. You have 5 teams, 10 teams, 7? How many teams you got? Huh? กี่ทีม What? 7 teams. Okay, let's aim for 20 minutes maybe. Okay, 20 plus. Now, you guys are going to be graded not only on your presentation, but your discussion involvement with your friend's presentation. Okay, so if this team presents, they'll get graded based on that. You guys will get graded based on your grilling them, basically, for lack of a better word. So you have to grill your friends as well. That's what the 5 minutes for. Okay, so let's make it like 20 plus 5 or something like that. Now, the way I would plan it, again, I would plan for a well-rehearsed 15-minute presentation. This is how I would do it. If I knew I had 20 minutes, I would plan a well-rehearsed 15 minutes. Okay, because in real life, it's not going to be that well-rehearsed, right? This is not acting job. But you prepare the script, you know, rehearse yourself so that you know that when it comes down to it, I can get all the message across in 15 minutes. In 15 minutes, I can tell the audience why I was looking at this problem, what's my interest in it, why does it matter, why is it a good project, get the audience invested. Okay, how do I think of this problem? This is my formulation. Okay, this is my methodology. I use this. This is machine learning supervisor. Why do I use this? Why do I use that? What's my implementation? Show a little bit of code, it's fine. Okay, but don't spend like 5 minutes on Python code. That's not going to be interesting. Show a little bit, fine. Okay, the tendency to show your work is very dangerous. Okay, try not to present what you want to present. Try to present what you think people want to see. Okay, what do I want to see? I want to see how you solve this problem. I want to see a little bit of coding as well. Like, oh, is it going to take like hundreds of lines of code, or is it simple function call? Like, you know, I would show it in Mathematica. See, you just make this mapping from this input, this output, and then you make this turn, and this is your output. Show how simple it is to replicate, but not all the details. So motivate, you know, say, oh, it's really easy. This library is good. TensorFlow is really easy. Scikit-learn is easy, or whatever. Okay, a little bit. Okay, you don't even have to show the actual program code. You can actually take the picture shot of program code and put in your presentation. Just highlight it. I've done that in the past. You know, to show people what the code would look like, but not in the programming environment but in the PowerPoint. Okay, so show that, right? in 15 minutes. Rehearse among yourself. Okay? And I don't want this kind of you know, if you want to take turns, and you should take turns, rehearse that. Okay? I'm the first speaker. Hand it out to this person. Boom. Okay? Just rehearse. Okay? Rehearse. Now, normally I tend to be speaking alone. So when I rehearse, I can do it in front of a mirror. You guys are different, right? It's a team thing. So you have to do this thing with one person speaking, sending to the other person to give the explanation and so forth. Rehearse that as a group, as a team. Nang look nang. Okay? So that should be next week. Then the exam. The exam is going to be just like the midterm. Well, obviously it won't be the midterm. It's be that kind of thing. Now, what I'm going to do is I'm going to give more weight to the bonus part. Okay? I'm going to give more weight to the bonus part. And I haven't, next week, after the presentation, or maybe even before, what I might do, thinking about doing, is just giving a list of papers. Okay? A list of papers, like maybe 10 papers. Okay? And in the bonus round or whatever, again, I'm putting a lot of weight, so you may not even think of it as bonus. Just think of as choice. You can choose which paper you like to discuss, but you have to discuss them. Okay? And this is where your synopsis experience comes into play. Okay? Now, you won't be writing a synopsis point by point, right? But you'll be writing like an essay. This paper approaches this problem. It develops from the previous paper by this and that. Now, how would I prepare for this? I would literally write the essay ahead of time. Okay? Now, you know, and this is simple. I tell you this. When I was a student, when I was a freshman, I was taking philosophy class. My philosophy professor said, these are the 5 questions. 3 of them will be on the exam. You know what I did? I wrote the entire essay and I memorized every word. Well, it's not difficult to memorize because as you write it, you follow the thinking, right? Same here. To memorize somebody else's word, that's very difficult. But if you write your own philosophical argument, you know, talking about Descartes and Kant and whatnot, and why this philosophy leads to contradiction and doesn't lead to contradiction, what's the theory of self, whatever, doesn't matter. Okay? I would write a whole paper. I think if I remember correctly, I wrote 3 papers, right? And I knew that they're going to be on it. Okay? At least 2 of them. So when I go to the exam, I just literally write my thoughts out, and it's well rehearsed. Okay? Because I know the argument, I know the philosophy, the philosophical argument I want to write. So that's what I would do. Read the paper, focus on the one you like, write an essay. Okay? Now, it wouldn't make sense if you guys work in groups, because it would make sense to help understand. But if you were to write, you know, and say, okay, can you help me write this? And no, that's not going to work. That's not going to work. Trust me. It's going to look funny because I'm not going to ask exactly an open question like, tell me about this picture, this paper. I'm going to ask something more specific. Okay? So you can prepare for the paper, but I'll say, well, in this paper, the 3rd equation says this. Okay? But prepare the whole essay. Okay, 3 groups. Questions? Okay, this is all the time you have, guys, because next week you're going to present. No. No. If you really want to, you can go to the internet and find out what project report write-up look like. Okay? And you should also know how to do this from your project management class, right? You do project class, right? Right? There's plenty of example. This is not a feeling. I could give you if I want, but that would be too easy. Okay, but I've literally done this. Okay, okay, so you can. Okay, so you know, literally, you just have all this: introduction, motivation, data, problem formulation, right? Method, experiment, result, conclusion, future work, caveat, discussion, whatever. Problem formulation is going to be where you can be technical about this, what we learned. You know, this is going to map into supervised learning. This is going to require that sort of thing. Okay. Last week, I think there was some of you attended the Pietro's class on Banpu. Yeah, like I'm helping them with that. Now, in that case, problem formulation is really a big section. Okay, they're doing what's called constraint optimization. Okay, this is something you guys haven't learned. We can discuss that when we have time. Okay, or whoever's interested. This is mathematical formulation. It's going to look like I'm going to maximize this f of x subject to g of x greater than equal to 0 or something like this. And then this is what defines the problem structure. This is how their logistic problem is defined. So they want to do like, well, Banpu is coal production and supply. So they have their own source of coal to supply to client. They also have third party. So how do you blend it? Okay, these are quantity that can be optimized vis-a-vis cost. There's also constraint like regulation or something. Okay, so the other teams, you guys are silent. I'm assuming that you're doing well. You have no problem, or oh my God. I don't mind answering questions in line group. Okay, I encourage you to ask in line group. But really, this is the time to ask if you have problems or issues right now. But you should know. Nope. No, don't just walk randomly unless you have something to do. Do you have to present something? Okay. It's not a coffee shop, guys. Your team is doing good. Oh, okay, so we talked already. You? The Erno shoe. So are you using the word to back? Understand? Okay, so what is your ground truth then? You have to have some kind of ground truth. Ground truth is certain words are negative. How are you going to determine that? Okay. So you'll be more likely to do something like a priori type analysis or frequency, word frequency. So anytime you deal with word frequency, I think a priori might be a good place to start. They do a lot of counting functions in there. Okay, but certainly if you don't need to do any kind of association or basket, but I think words occur in baskets in that case, right? Maybe certain word like I love you and I don't know, nice sunset or something like that. Sure. This is called subsampling. You don't have to certain word like the or N or yeah. So certainly, what is your analysis then? Just going to say that whether or not they have different word frequency. Again, you have to have ground truth on negative and positiveness. How are you going to do that? Okay, so you have a dictionary of root words. Okay, so that's fine. You have, and so the negative is a binary thing, right? It's either root or not root. There's not a scale of sweet word to root word. Okay, so this is some kind of frequency analysis. What's your programming language? Okay, so check out a priori. There'll probably be a lot of easy counting functions in there. Okay, but you have like a library of text, right? Library of lyrics. Yeah, that's not too difficult. If you, I mean, word lyrics are not that difficult. English to Thai song. English is even easier, right? You literally can just have a very quick program that takes a text and just list words and count, okay? And then you can have a list of words you don't want to count, like D or I or U, or you have words that you consider root word or something like that. But this is not really that good of an exercise, because if you want to do negative or positive, you have to attach sentiment to it. Okay, so this would be something like sentiment modeling. So now, one thing that you can do, and this is something for the team that haven't done a lot of complete work. If you've done complete work, you can say, this is my approach, this is my data, I got the result, I'm happy, blah, 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 you can use it. But for teams, especially like you, let's say you have done this word frequency, and you're just counting the root word, but you really want to do sentiment. Okay, so your methodology doesn't answer that. This introduction part, the biggest part that you can boost, is called literature survey. Now, technically, literature survey is part of your method. Okay, it's part of your method. But in this case, if you really haven't, well, what I'm trying to say is this: when you do a literature survey, that should give you the rationale for choosing your methodology, right? But if you really haven't gone deep into the methodology, let's say you find sentiment analysis and there are 500 papers, but you're not using any of them, okay? You're not using any of them. You're just counting words that are root, which is a very simple technique. What you might do is boost the presentation with a literature survey section separately. Okay, that'd be okay as well. Okay, so for the project that haven't done very well, or you're not getting any result, you're not doing a lot of programming, and you're not getting, just sort of like do a little box or something, like a literature survey, a big literature survey, so you can get points for that. Okay. This is a difference between project write-up and academic paper. Academic paper, you have to declare where you are. That means you have to do a literature survey. This is what people did. This is what this guy did. This is what this guy did. They found this. They found this. We are going to do this. We are going to do this. You have to place just, otherwise we can't tell whether you're making a breakthrough, right? You say, oh, they've done this, but they run into problems. They've done this, they've done this, but they haven't done this. So we're going to do this. So literature survey is a big part of academic paper. In a project, the literature survey is important to assure the project owner or the audience that you actually have tried decent method. There are decent methods out there. You try them all, or you're not being silly. Okay? So they've done sentiment analysis, so you use that technique. Now, in your case, if you haven't, I would allow you to make a little separate section that say like literature survey on this, and say, these are the things that people have done. I read them, I describe them briefly, like a synopsis or whatever, but I'm not gonna do them because I don't have time. It's okay. You're allowed to do that, okay? But normally a project write-up paper would not have a large literature survey. It would only tell you the literature survey so you know what kind of approach we are using, okay? It's just a context thing. It's not a big part, literature survey, of a project write-up, okay? But again, if your project are not delivering on promise, okay? If you're not, going deep into the things that you want to do, you can beef up the presentation by having a big literature survey section. And that's something that everybody can contribute. So if, let's say you two are tied up with programming, then the rest can write on the literature survey. Okay? So maybe I don't want to really, but I could make a little example, but you see this already. I don't want to. Okay? So look up things like, how to do a proper project write-up. How to write academic conference paper or journal paper, okay? And that's the easiest thing, is just to look at example. Yeah, I just send you the original paper for Word2Vec. That's very nice paper to read. It's not that long, and that gives you the idea of how academic papers are written. Very good paper, very, very good. It's two papers together. They come together to define Word2Vec. Okay, so that's that. Next week, okay, come on time, okay, because you never know who's going to be first. Okay, 9 o'clock sharp. If you're not ready to present, okay, you're out of luck. Okay, so I'm gonna do, say you're supposed to be the first team. You have 20 minutes. Okay, if you don't show up, you show up the last 5 minutes. You have 5 minutes. Okay, so next week we're gonna be very stringent on time. I'm just gonna sit somewhere in the back. Enjoy the show. Okay. So rehearse. Okay. And the exam again is going to be conceptual, which most of you did well. There, like I said, there's only 3 or 4 of you who really, didn't manage. But most of you kind of understood the concept pretty well. Okay. So we do that. Good. Yeah, if you have itty-bitty issue about programming, maybe ask your TA as well. Okay, but other than that, it's quite simple. Again, for those using Mathematica, you don't have to use the in help. You just go Google, just write Mathematica and how to do this. And people who have done it plenty of times will show you. Same with Python. Okay, just whatever question you have, you put in a double quote. Like if you want to use scikit-learn, you just put scikit-learn in a double quote. So you make sure that all the questions that you ask later, the Google will only filter out those that have scikit-learn. Okay. Okay, Kap. I think that's good enough for today. See you next week. สวัสดีจ้ะ